Hello everyone. In this video, I want to explain magnetism. Like electrostatic, in electrostatic there are stationary charges, positive or negative. In the case of electromagnetism, there is north pole, south pole. North pole, south pole attracts, means unlike poles are attracted by each other and like poles are repelled by each other. Magnets have two ends called poles, north pole and south pole. There are no single poles, means monopole does not exist. Like poles repel, opposite poles attract. Now, magnetism. It was discovered that running current through a wire produces a magnet. The magnetism around permanent magnets and currents are very similar, so both must have common cause. Current is the cause of all magnetism. So one of the type ferromagnetism, magnetic material have an unpaired outer electron. Atoms near each other lines up so that the unpaired electrons spin the same direction. This spinning creates magnetism. In permanent magnet, the current is electrons in atom move around nucleus and spin. Most cancel out except in ferromagnetic materials. Ferromagnetic materials, electron magnetic effect does not cancel over large groups of atoms. That is known as domain. This gives small magnetic region size. Its size varies from 0.01 to 0.1 millimeter, called magnetic domains. In a permanent magnet, these domains are aligned, like as this. This blue line indicates demo. Okay, domain. This domain is in this direction. This domain like opposite direction of this. So inside the domain, every atom aligned. But overall, overall the crystal domains are in different aligned. Common magnetic materials are iron, nickel, cobalt, and chromium dioxide, etc. These are magnetic domains. Okay, this is unmagnetized iron. When you bring it near the permanent magnet, then it aligns itself. Its arrow side indicates north, and tail side indicates south. That's why in the magnet, here I am towards this domain, there is S, south pole, and domain's north pole is attracted by this. Induced magnetism. Usually, the magnetic domains are randomly arranged. When it is placed in magnetic field, B field, the domains that are aligned with the V field grow larger and the orientation of other domains may rotate until they are aligned. This gives the material and overall magnetism. Around a magnet is a magnetic field. At every point in space, there is a magnetic force. Can be seen with compass. Its unit is Tesla. Magnetic fields can be visualized with field lines like this. The North Pole, South Pole. In case of electrostatic, we have seen that positive charge generates the electric line of force and negative ends up. Similar, in this case, north pole generates the electric magnetic field lines and south pole it merges at south pole. This is the under software north pole south pole visualization. At it starts magnetic field line starts north pole and end at south pole. The more lines in one area means stronger field, just like electric line of force. Since currents, this is due to moving charge, make magnetic field, then other magnetic fields apply a force to moving charges. For a moving charge to experience a force, charge must be moving. These are the conditions. The velocity vector of the charge must have a component perpendicular to the magnetic field. Then it's called Lorentz magnetic force. So force, this is the force by that uniform magnetic field on that moving charge. F is equal to Q V cross V. V is magnetic field, V is velocity of that moving charge, and Q is magnitude. Then it will comes Q V B sine theta, where force, charge, speed of charge. So magnetic field. Theta is angle between velocity and field. Now direction of force on positive moving charge is called a right hand rule. When fingers points in the direction of field, thumb in direction of moving charge, then palm face direction of force on positive charge. This is the second case when force will be zero when V and V are parallel, means velocity, motion of the charge and field are making angle 0 degree are parallel. Okay, so a moving charge will be unaffected like this. This is north pole, so south pole, so field, uniform magnetic field, and we are inserting here positive charge in this line like this. It will be unaffected due to this field. The motion of moving charge particle in uniform field, magnetic field, so circular. Here the magnitude is QVV sine theta. This centripetal force will equal to mv square upon r, as you know that. That's why we are equating these two forces and finally got QVV sine theta is equal to mv square upon r. Finally, r that is the radius of the circle, will equal to mv upon q, force on a current carrying wire in magnetic field. Direction follows right hand rule, just above previous slide. When conductor current carrying conductor in this direction, so wire of length, conductor's length, palm indicates field, and force will be upper direction. The magnitude of force is Q B V sine theta, and we are inserting here value. We are simple inserting T here. We are making current Q upon T here. That's why I'm multiplying T as well as dividing by T. It makes QTI and VT that is velocity into time that is length. F is equal to ILV sine. Now Ampere's law. Summation of V dot L delta L is equal to mu naught I. It's a closed path. In is a closed path. These are two conductors carrying current I1 and I2. This is for first one, this is for second one. Where V is the magnetic field, this V is the magnetic field, and this B is the field, magnetic field parallel to L, length of conductor. Then delta L, a portion of the path surround the current. Okay, this small dl. This is a small dl. So little one, small one portion of this enclosed path. Mu naught is permeability of free space and its magnitude is 4 pi into 10 raised power minus 7 Tesla meter per ampere. I is current enclosed by the. This is next one. We are making it as a simple case. Then this straight long conductor carrying current I in upward direction y axis. At the point P, somewhere P, we are taking a circular path and length of this circular path I am taking small l. At that point, field's direction is parallel to this dl. B dot dl is equal to mu naught I. This Ampere's circuital law. We are simply inserting the value of this whole circle, that is 2 pi r. Then this field is for a total circle now. Okay, it is 2b times 2 pi r is equal to mu naught I. Finally, we got magnetic field will equal to mu naught I upon 2 pi r. This is for this long conductor. Okay. Now, electrical current through a wire. Wire is straight. Here is also right-hand rule like this. But in this case, thumb in upward direction and fingers are curved. The direction of thumb indicates direction of current and this curled finger indicates field. Grab the wire with right hand, thumb points in direction of current, finger curls in direction of magnetic field, like this. Then finally magnetic field this is equal to, its magnitude is equal to mu naught I upon 2 pi r, as we had done in previous slide. Now in loop, right hand rule, at the center of loop, like this, when you thumb curl and thumb slightly bent, like is this loop, we this direction of fingers gives the direction of field, is just like this. B is equal to n mu naught I upon 2r. So where capital N is number of loops. This is for now solenoidal case. This one, as you know, solenoids construction is like as this, and we are applying same right hand rule here. North pole. Okay, this is solenoid, direction of current. It looks like this. It's north pole now, south pole. Outside this solenoid is bigger magnetic field. That is negligible one. Okay, this solenoid is now the combination of large number of these type loops. Okay, that's why here is inserting here n number of loops. Finally, B field by this solenoid will equal to mu naught n I. where small n indicates loops per meter. Magnetic flux through a surface. As we know that flux is equal to V dot A, having vector. Is a dot product, that's why taking cos phi. The angle between the field and the normal to the surface. This is a normal, this is normal, and this is a field, and we are making angle phi. The component of this vector parallel to horizontal surface or normal, there is B cos phi. The magnetic flux is proportional to the number of field lines that pass through a surface. Any change in magnetic flux causes a current to flow. I've done in short form about solenoid, loop, etc. I'm not inserting its derivation. Thank you for your attention or watching this video.